Hello everybody, welcome to our FEM-Design related to reinforced concrete design webinar. For today, I will be your host. My name is Ciprian Tibia. I am the sales manager of Baltic countries, Romania, and rest of the world. And I will be joined by my colleague Anders, which is a technical expert, and he will answer your questions in the background. So any questions that will arise during the presentation, please use the raise hand or question field, and Anders will do his best to answer it right away. All right, so for today, I planned a few subjects related to RC design and an article which was shared on LinkedIn on our official page in last days. I can't recall exactly how many. In which one of our colleagues has made a comparative study on one of the features implemented in version 21. And he came up to the conclusion that there is quite a lot of reinforcement saved by using that feature compared to the previous features that existed in version 20. Among other subjects, we will discuss about the punching shear, the beam column reinforcement design, the concealed bar design, the crack section analysis. So yeah, I prepared a little bit of theory before, and then we will jump to building a quick model and going through all of these subjects. So for the punching shear, is calculated according to Eurocode 2. The regions are defined automatically, and the beta factor, of course, is calculated depending on the position of the column in our plate. All right, then the concealed bar, which basically a concealed bar can be a part of a wall, which is above a door opening or window that you want to, it's quite narrow, and you want to reinforce as a beam, not as a wall. So then you will just use this concealed bar function. Then, as I said, we will go through the cracked section analysis, which covers that displacement of plates, walls, columns, and beams can be calculated based on their crack state and designed reinforcement. Yeah, now we will jump to the article first, and afterwards we will jump to FEM-Design. But first, just a few updates maybe about how Strusoft has evolved in terms of locations across the globe, the offices, and of course at the end of the webinar we will discuss about trials and yeah, inquiries, demos, etc. All right, I will share this link with you. Hopefully I can do this. All right, I hope everybody got it. So basically, what do my colleagues did here in this article? As I said, they compared version 20 features with version 21 features. And it's about the new layout option called minimal area of rectangles. And as I said, they came out to the conclusion that there is about roughly 22% saving in reinforcement. Now, of course, this is if you use the automatic design for the plates in version 20 and in version 21. If you use to manually design the reinforcement, then of course it has no importance. This is the quantities in tons, and this is the difference. So let's go to FEM-Design now. I will also address a little bit, I know for the experienced users might be boring what I'm going to do now, but I promise it's just a very simplistic model, and it should not take too much time. So we take a square column, let's say 400. And then we place it, because I have the grid section at 2 meters, we place the columns 6 meters in between, like this. And then we just copy them, again 6 meters. All right, then we add a plate, and because we want to talk about punching shear, we make it a little bit thicker. Then we can discuss about concealed bar in this model as well. So then we will need a wall panel. And we need to cut an opening. All right, now we should add the supports. All right. And now our structure is almost ready. We should define some loads. Okay, and some load combination. 1. All right, and now we should move to the, oops, sorry. I defined the loads, but I didn't add them. So let's place 8 kilonewton per square meter. Permanent, maybe 5 the live load. Okay. All right, so now our building is calculated. We can proceed to reinforced concrete design. And first, let's define the concealed bar. I think I will need a line to help me do that. So this region above the door opening, I would like it to be designed as a bar element. So now I defined the concealed bar region, and when I will calculate the elements, it will add reinforcement exactly as in B. Okay. Then if we go to the punching shear, and if you remember what we discussed about that beta parameter, now we can of course calculate it automatically, or we can manually tell the software that this is a corner column, this is a edge column, so on and so forth. Column. Okay, and yeah, we can afterwards select the type of reinforcement, the type of punching shear reinforcement that we want to use. But first, let's do normal design, and then we will tweak it along the way. So if I just click the calculate and auto design all structural elements, if I go, it was already designed. If I just want to view it, then this is the calculation, and apparently I don't need any reinforcement, so I should increase the load. Okay, let's go and increase the loads. If we want to go into the crack analysis as well, we should select the crack analysis and the second order. It will give me a warning that I have no reinforcement and it will be ignored, but in FEM-Design, there are a multitude of ways to design punching shear. You can either use bake or punching shear reinforcement, made in situ reinforcements, circular stirrups, etc. You will see in a moment. So for those two, I let the software decide automatically, but we can use, for example, a banded bar. Sorry. Or PSP, or circular, as I said, open stirrups. All those possibilities, depending on the project, can be used to design the punching shear reinforcement. All right. So if we move and design all of them, apparently the corner ones are okay. And if I want to view the detailed results for one of them, we can just click the magnifying glass, and it will take me to the calculation, to all of the details, and I can print those results and add them to my calculation notes. Okay, now let's see what the software did to our concealed bar. Sorry. Currently nothing. Because I didn't design. I was under the feeling that it was already designed. So this is how my concealed bar looks. As I said, it has stirrups, as you can see here, and longitudinal reinforcement as well, and the calculation notes to accompany it. Input data, calculation formulas used, tables with designed values. Everything you need is here. And again, you can use it, in your calculation notes, or you can just add it in the report to be printed out at the end. Okay, this concealed bar has other uses as well, depending on the project and the wall part. If you want to design a tip beam, you can use it, design it initially as a wall, and then use this concealed bar function, and then you basically have a dip beam. Okay, then yeah, let's move to our beam and column. So if I go to the layers, there is an easier way to view the reinforcement by just enabling this layer RC bar design parameters. And then I can see on the section which column the reinforcement that was designed automatically. But of course, I can also manually design, the concealed bar. Everything basically can be manually designed. So just select this one, and it will take me to this window where I can even view the column in 3D. Now I can play with the reinforcement, with the steering, with the longitudinal reinforcement. If it's a composed with a applied section. So yeah, basically here is the place where if you are not satisfied with the automatic design that FEM-Design made, you can just exchange it, and do whatever you want, and then just check it to see what is your utilization rate, if whether your column is designed okay, or you have to still modify something. And then it's the same for beams. And then the next part that I wanted to go through was the correct analysis. So this is let's say a pattern on how the cracking looks like. You see here it's cracking considered, second order theory, and load combination 2. There is also the possibility to check a box and see if whether you allow the cracks to reopen or not. Basically, the default analysis is that simple. Everything, as you see, it's really easy to perform in FEM-Design, and yeah, I hope you guys jump straight to it if you are not already using it, because this is just like small things in its functionality that we wanted to present to you today. All right. I don't know if whether I forgot anything. I am usually going fast forward, so now I will just take a peek to the questions to see if whether on this correct section it was a quasi-permanent state. So it was not the ultimate limit state. All right. If there aren't any other questions, I thank you for your attention. I didn't steal too much of your time, but if somebody is interested to have a one-on-one demo with either me or one of my colleagues, please do not hesitate to just send us an email. For the new users, we always have free courses to start you up. And then, of course, you will get a trial. For existing users, you always have the possibility to contact our awesome support, which is not taking more than 48 hours in some really difficult cases to respond. In simple cases, it will be within a couple of hours time. So thank you, and hope to see you in our next webinar.